Alright, so let's do this a fourth time here. Revolving a region in the xy plane about a vertical axis. So find the volume of the solid generated by revolving the region in the first quadrant, bounded by y equals the square root of x and y equals x cubed about the line x equals 8. Please pause the video and go try the problem. Sketch the region, sketch the axis, sketch the rectangle, and get the information that you need together to solve the problem. Try to solve the problem, okay? Just note, we're going to just set up an integral. We're not going to actually evaluate the integral here. You could do that on your calculator or work it out by hand. We're just going to get to the point where we can set up the integral properly. All right. So here's my rough sketch of the two curves, root x and the cubic x cubed. They intersect here at the point 1, 1. And so we just need to now take this region here and revolve it around x equals 8. Let's suppose x equals 8 is out over here. And if we draw our little representative rectangles like we've been doing, like this, and we have our delta y right here, we need to identify our inner and outer radii and then go through the process of finding the volume. So our outer radii will be from the edge of the rectangle that's furthest from the vertical edge of the rectangle that's furthest from x equals 8. So it's going to start out here and go all the way over to here. That's going to be our outer radius. And then the vertical edge that's closest to x equals 8 is going to help us define our inner radius, that length there. And as we said before, in the xy plane, horizontal length is found by right minus left. The general principle is greater minus lesser. And in order to do that, horizontally, it's right minus left. And so in each case, our right function here is the vertical axis 8. The left will be the appropriate curve that it's near. And since, again, our curves were given in terms of y in terms of x, we need to solve each of them for x in terms of y. So I'll put this throughout the screen here. I hope it doesn't cloud it too much for us. So we were given that y is equal to the square root of x as one of our curves. So now we're going to have x is equal to y squared. And that's going to help define the outer radius, because our outer radius here is given by this portion over here, which is coming from the square root graph, or in terms x in terms of y, x equals y squared, the upper part of that sleeping parabola. And so the outer radius is going to be 8 minus y squared. The inner radius, let me see if I can squeeze this in on this side. We were given y equals x cubed. And so x is going to be the cube root of y. And as we can see, the inner rectangle here is the inner part for our inner radius. That part of the rectangle is butting up against the cubic, and so our inner radius is going to be 8 minus the cube root of y. And so now that we have our inner and outer radii, we can go ahead and find the area of the cross section. So our cross section is this washer that we've been dealing with, and so we're going to have pi times the square of the outer radius minus the square of the inner radius. And as we said before, our outer radius is going to be 8 minus y squared, and so we'll have 8 minus y squared quantity squared minus the inner radius, which was 8 minus the cube root of y, so we'll have 8 minus cube root of y quantity squared, and then close off that bracket. Now we have the area of the cross section. We just need to remind ourselves what the upper and lower limits of integration are going to be for our integral. Since we're dealing with the delta y, we are integrating vertically, and so we're integrating from the y-axis, or from the x-axis, excuse me, all the way up to the point of intersection here. And so we're starting down here at 0, we're going all the way up to 1. maybe I need to do some varied examples, so because that's been our common upper and lower limits for the last few examples here, but it's okay. So our volume is the integral from 0 to 1 pi times this quantity here, 8 minus y squared quantity squared. We got minus 8 minus the cube root of y quantity squared, and then we have our dy out over there. Once again, we could evaluate this on our calculators if it's on a calculator portion of the AP exam, and if it's not on the calculator portion, then we could either, depends on the question. The question may just say find the integral that represents the volume of the solid, and we could stop here. If it said to find the volume, we didn't have a calculator, we'd have to work this out by hand all the way through. So we would square out each term, collect like terms, and then find the antiderivatives of each term in order to find our solution. Hopefully you got that answer, and hopefully you're getting the hang of this stuff, because I don't think it's that hard. I think you guys can all understand it. You just need to get the practice. All right.